Now we're going to discuss solving linear inequalities, and the process for solving inequalities is almost identical to solving equations. One difference, which you guys are probably familiar with, is here in this box. It says remember to reverse the inequality, to flip it, if you multiply or divide the inequality by a negative number, by a negative constant. So that means if you have negative 5x is greater than 10, and you divide both sides by the negative 5, that will then become x is less than negative 2. So when you're dividing by that negative 5, you flip that inequality. All right, I also wrote in yellow down here, I recommend putting x on the left of your inequality symbol. So for example, if you solve an inequality and you get 2 is greater than x, I would go ahead and flip this to the equivalent x is less than 2. And I'm not saying anything new. This is just like getting, 2 equals x and rewriting it as x equals 2. It's just a formatting thing. The only thing is the direction of your inequality matters when you flip the x and the 2. If 2 is always greater than x, then x is always going to be less than 2. And the reason I recommend writing your variable on the left is when it comes to graphing on a line graph, I see students make a lot of mistakes on their graphs if they've got 2 greater than x. And then I see them pretty confident and getting correct answers with x less than 2. So it's just a little less mistake prone. All right, so looking at number 5, solve and graph the solution set. So maybe our first move would be to add 2x to both sides. So that gives me negative 5x minus 5 greater than or equal to 10. And then I could add 5 to both sides. So negative 5x greater than or equal to positive 15. So here we're dividing both sides by a negative constant. And that means we're going to need to flip this inequality. So on the left, I just have x. I'm going to change greater than or equal to less than or equal to. 15 divided by negative 5 gives me negative 3. So that's the inequality. To graph this, x less than or equal to negative 3, I'm going to put a square bracket at negative 3, draw my arrow out to the left. And in interval notation, remember that negative infinity is way out here. So from the left, I have negative infinity. Going to the right, I have negative 3, square bracket before that, less than or equal to sign. Right? And I just want to caution you, a lot of times I would say the main mistake I see students making when they're solving linear inequalities is they start off with this. So the same inequality we had for question number 5. And then from the first step, when they add 2x, they have, for example, negative 5x minus 5. And then they just are like, I don't like inequalities. And they write an equal sign. And then they keep the equal sign going. And then at the very end, they're like, I guess I'll make it a greater than or equal to. But don't do that, okay? So notice that as I was going through, I always wrote an inequality, whether it needed to be flipped or not. I never put an equal sign there. So don't be sloppy about that. Make sure you're writing your inequality. And then if you flip it, make sure to flip it as soon as you need to. So just keep an eye on that. All right, looking at number 6. So now we have what's called a compound inequality. And my x is here in the middle of those two inequality symbols, so I want to isolate x. So my first move to isolate x is to subtract away that 1. And notice that I'm doing this in 1, 2, 3 spots. There, and there. So I have negative 5 is less than negative 5x, less than or equal to positive 10. And now I'm going to divide by my constant negative 5 to continue isolating x. But notice that when I divide by this constant, this negative constant, I'm going to also flip my inequalities, right? So on the left, I have positive 1 greater than, and I just have x in the middle, greater than or equal to negative 2. So what I wrote is correct. However, it's kind of poor math grammar. If you look at any compound inequality that you run into, you might not have thought about this before, but we always write compound inequalities. You'll always see a compound inequality written with less than or equal to symbols. And the reason for that is so that we can read the inequality from left to right. So if you think of our number line, here's 1, here's -2. Right now our compound inequality is leading from right to left. We want to flip this around so that we can read it from left to right and use less than or equal to inequalities. So I'm going to flip this whole thing around. I'm going to put my -2 here, my 1 here, and my x in the middle. So inside the inequality, if x is greater than or equal to -2, that means -2 is less than or equal to x, right? Those are the same statements. Over here, if 1 is greater than x, that means that x is less than 1. So I want to rotate the whole thing around so that I can read it from left to right. And when I do that, you'll see that your compound inequality is written only with less than or equal to inequalities. Okay, so let's go ahead and graph this. -2, square bracket, +1, rounded parenthesis, and connect the two together. And in interval notation, square bracket, -2, 1, rounded parenthesis.